Okay, so
Move on.
it's okay. Yeah, I think I'll just move on. So basically, that sums up the four languages that how I kind of self-evaluate my projects or determine the directions that I want each project to go, and also kind of the teaching in school. Uh, then so research and thinking forms a big part of. We are not reactive. We try to fit the brief and the program into the design rather than being determined by what the client wants. Okay, so it's not how to say, I think both are important, but it cannot be either, right? So I'll go into Space House, and this was built with Arc Studio with Peng Beng and Belinda, so they were my old bosses. And then we started then. It was amazing project. The client was amazing. It was their 22nd house. So by then they are really quite bored of those boxy Cartesian houses with columns. So the brief from the client was that I want this house to be like an alien, or a spaceship that's just landed. And these were the 5 or 6 words that should describe the house: wacky, wild, warm, whimsical, weird, and wrong, right? So as you can see from the beginning, I think we did, I don't know, 10, 20 different schemes, different at the concept stage, right? To go through basically all the languages that you can have, that is familiar and not familiar. And the, uh, a lot of the earlier schemes were centered around this uh, curvy schemes, right? That is, so you can see, right? So some of this is like a bit like parametric form, like Zaha's building and things like curves like that. Then eventually, uh, I think one day I got tired of this curve, and I made this model in the middle. So I was like, what if the whole building is just made of triangles? So I made this model. So everything is made of triangles. And on the day of presentation, the client walk in with a Issey Miyake bag. So that's it's form of all these origami triangles. And I don't know, by chance or coincidence, this scheme finally got selected and uh to build, right? So from this something so conceptual, we made I don't know 10 more models. So you can see here like all these red lines and all these orange lines. These are all URA's regulations. So regulations in Singapore is very tight. And basically it was so difficult to comply with the regulations. But also when we did submission, usually we only have to submit drawings, but the planners were not able to conceive or imagine a form. So actually we have to do model submission. Now you have been, but this is 2013, so it was like um something new, right? So we have to show them the real model, like meet them to so that they can understand what the building looks like. So it went through many rounds of thing, and then finally this is the final one. So basically the building is very simple. It's based on 5 volumes made of triangles, like crystal. And then the middle part is an art gallery and also circulation. So this is a staircase to enter the house. This is the entrance, and there's a back staircase. So the whole thing is to display their art, right? So these 5 volumes are basically living spaces. So everything else, including the landscape and the car porch, everything else is made of freeform curves. Freeform curves means they are not arc or circle, right? They are basically really like freehand, free flow curves, right? So I'm going to go through, uh, this is the model, the final form in the model. And this is what is published. So I'm going to go through how we built this. It's a close-up, so you can see not just the outside, but all the cladding, everything is triangle in this unit. Okay, So the idea is that, you know, there are 7 types of existing crystal structure, right? They are made of cubic, this whole table here on the left, right? So here we are trying to define the form based on 8 vertices, right? So each, there are 2 stories, and then therefore 3 layers of vertices. So each layer has 8 points, and these points are being distorted by views, by functional requirement, right? They extend or distort out, right? And then after that, these points are then joined together to form the volume, right? So these lines and points, these are also the key structural framing element, which means it's not a vertical column and then we make a slanting wall. The slanting thing is a concrete, so every one of this line is a beam, right? So it's not like a column and then beam and then you make a slanting wall. Okay, so if we join all the 5 volumes together, this is what we get. And this is the first step. And why this is important is because we then have to communicate to the engineer. How do we call all these points? Because we are not having grid lines, right? So we start to name the volumes, and then we start to come up with a system to name each of these points. Like this one is 1, 1, then this is 2, 1, this is 3, 1, right? So that as we work and communicate over the phone with the contractor as well, we can know exactly which point each other is talking about. And to make this, so this is the structure, and then we use the computer software and we make all this triangular shape. Why? So this is like origami. So if you cut them and fold them, eventually they can wrap around this structure frame, and then we can build model very quickly to study, right? So we are using a lot of computer modeling software, and we are also using a lot of handmade models. So from the origami just now that you see, we can make volumes like that, right? For each, to see each space. And also on the right, you can see 2 volumes are stacked up, and we start to basically draw double line, and these are all the concrete truss, which is the structure, right? So this is to discuss, right, with the engineer how we need to shift some of these points to achieve structural stability. So from here, so usually we just issue plans and sections to the engineer, but this we have to issue a set of models like that to the engineer as well to study, so that they can also model in their structural software, right? So eventually the engineer came up with drawings like this, and you can see that again we can describe every point accurately, right? And then these red lines eventually forms our plastering groove line so that the plaster doesn't crack, right? So it's the red lines will be, it's a subdivision of the bigger triangles in black lines. Okay, so we have to draw differently, we have to make model to even to communicate and for the contractor to build. So this is on site, and this is the formwork made by the contractor. And you can see right here, we have 3 columns, not, if you want like truss, I'll call it space truss, right? Not columns because they're not vertical. And this is the caging. And then we ran into the problem. So you see this photo on the right, right? We ran into a problem because why? This is actually this note here, right? On KO5 volume. We have too many overlapping rebars because you have all the rebars coming in and the overlap is too dense. So basically the concrete cannot be poured through it because the gaps is smaller than the aggregates in the concrete, right? So we took the contractor took the most dense structural node and made this and to test, and true enough, we cannot pour through, so we have to come up with a solution. So this is the solution. So for the very dense nodes, we basically have to make a steel plate, and then the rebars is welded onto the steel plate so they don't overlap for these nodes, right? So there's only a plate, two plates, and you can pour concrete through. And you okay, so that is the triangular part of the building. Now we go to this. So this is all the structural nodes, and then now we go to this free-form curvy part of the building, right? So the most difficult is the staircase, the front staircase envelope. So this is the final thing, how it looks like. But we started with basically very big model. So I have a very good colleague. He makes very good model. So he basically made this, and we envision something to be very light, very thin, right? So a lot of fins, and they are all in free-form curves. They are not a perfect circle, right? So, and it's being stacked up. So this is the build. This is the drawing of the section of that of this. So this is all design stage, right? And then we start to look at all these details and how are we going to construct this, right? So the first proposal was, what if it's concrete? And this is the kind of detailing kind of that we want. So for the fins to look lightweight, you need to make it quite thin on the edge, right? But concrete will crack if it's too thin. So the middle part basically has to be thickened, right? And then after we thicken and do part of the fin, this is not even the full thickness on the right. As you can see the filling, this is the full scale mock-up that the contractor did on site, right? The filling is not quite like the model, right? Which is so light, and this is just very heavy, and there are so many of them. So it's just wrong. So we have to find another solution. So I went back to model this. We use Rhino a lot, and basically took each of these fins. What if we take the profile and we just laser cut steel plates, right? Very thin steel plates overseas in China, and then it can be delivered maybe a few parts, right? And then assemble on site. But the whole idea is that we are now from something like 220 cm thick to 20 mm, right? So this is the new detail. Then of course we had very, very good structure engineer, web structure. And this is the detail that we have. And for the water to flow, actually every vertical element has to be slightly slanted so that the water will flow outwards. Okay, before that, you see all these vertical elements. So another thing that we are quite sure we don't want after this mock-up is that we don't want this 5 of these very heavy beams or ribs supporting this whole thing, right? So it has, we don't want like 1, 2, 3, 4, 5 stringer. So then I propose vertical plates, right? This small little scattered vertical plates all over the fins, like this, as you can see, right? So instead of one very thick one, this is, we are now down to 20 and scattered and staggered all over the fins. So it forms more like a net rather than, you know, like the main supporting beam and then secondary fins. So again, this is back to the first project that I showed you on paper structure, like something that I like about non-hierarchical things, how we can make very small, lightweight material work as a network to hold up the weight rather than having something members that is very, very robust, right? So you can see on the left, this is the design, large scale design model, and then put in the middle under construction. They assemble and they're adjusting all these profiles such that so that the water all flows out. and the final thing on the right that you can see here. Okay, and again, on the left is the model, on the right is the completed photo looking from below. So every one of these fin, they are laser cut directly from the rhino model, and then it's laser cut in China, right? Every piece is then assembled on site. So on the right, you can see the fins and the vertical members from inside again. So this is here. Okay, so this is very difficult. Now I show you the rest of the, so basically all the freeform curves, they are all very difficult. When the contractor first started this project, they even have problem basically plotting out this curve on site, right? It's like, how do you make sure that you are accurate on site, right? And how do I mark up all these things, right? In the end, we found a method using the rebar. So you bend rebar and then to mark points, right? So eventually, um, we so they built the pool first. So after learning how to build two freeform curves, they can then handle this staircase, right? So these more photos of the model. So the middle part where the art gallery is two levels and it's freeform. And then this is the on the right is the back staircase, right? So this is the powder room also in the middle, and this is the light quality. So this is photo of the model as well. So when you build models that are built big enough, you can actually see the actual light quality, right? So there's a lot of natural light coming into this gallery because they don't believe in expensive art. They believe in, so it's very interesting. So this is the photo of the final space, interior space. I can't show too many photos because of privacy, but yeah, so you can see that it's quite close to the kind of light that we get, you know. So we don't really believe in rendering. I think large scale models are more accurate, and this is learning from the Japanese, right? Then after that, so I finished this project and then I started my own firm. And 2 3 years later, the client contacted me. Basically, they want to uh, do something about their back garden because there's a lot of it's lower near the boundary wall, so there's a lot of flooding that's happening at the back garden. So they want me to design like a hardscape garden. Instead, it was all planted and it was also overgrown. So they wanted just to have a dryscape garden. So I have to do something that kind of not destroy the original design, right? So continuing the curve language, I came up with this different landscape terraces, and the curves are again where they expand is where you can then look at, sit and admire the building itself, right? And then eventually, so the perimeter is higher, it steps down to a lower area, the blue area here, and it collects the rainwater. So this is where all the rainwater will be drained off and to the drain, to the perimeter drain, right? So it's kind of functional, but you can't make it, uh, it's not determined by the function, right? So this is the section of that landscape garden. This is the, on the right, the swimming pool. And then we have to determine where it will start flooding. And then, so depending on less or more water, the landscape garden will expand and contract, right? On the left, they also have a Zaha Hadid sculpture on the left. So that's for Zaha Hadid. Okay, so again, yeah, I made a lot of models to kind of check the flow of the landscape and to see whether it gels with the existing house. This is what is built, right? So this is the back garden now, and you can just sit around and you can admire the original building, right? And the part in the middle you can see, so that's where the water drains off. This is in a day, and uh, the plantings quite lush. They always change the planting, right? So this is the kind of like the functional drain where it drains off the water. This is the So by then the contractor is very experienced in like building this kind of irregular freeform shape. We learned a lot. I'm going to show you. So this is actually the tile drawings, right? The curve border, these are all again laser cut granite from China. So we had to give them the cutting list and it's cut and then it's just installed here. The infill, these are tiles. So these are just rectangular tiles. These are cut on site by local craftsmen and they are installed on site, right? So these are easy. They just trim off the edges. But this border, this is very difficult, right? So is precise, but there's also construction error on site, right? So we have to kind of give more tolerance so that we can, what they cut and deliver can fit on site, right? So we learn from, this is kind of the mock-up that we did for the car porch in the original construction. The car porch is actually a circle. So that's supposed to be very easy, right? Circle. So you can see here on the right, on site, they nail a piece of wood and they try to mark out the different, it's circular, but basically there's different rings of granite stones of different sizes. Okay, so they did, they simulate the stone granite sizes and they start to install, right, to just to make sure to go through the client that if we are using standard rectangular sizes, we are going to have groove line that goes from very small to very big. That's cheaper. If this is not acceptable, then every piece will be a trapezoidal shape. So they then have to kind of laser cut again the stone to make it the right fan shape. I think in the end we went with this rectangular shape, right? So this is the tailor trying to install this. So it's, you see the driveway, you drive in and you start having these lines, right? But these curves, these are not freeform curves because of the car, right? The car needs a perfect circle. So this is the only perfect circle that we have in the house. And but we started with this, right, to learn kind of the lesson. And this is actually the pool coping. So when we get to the pool and the landscape, this is where we have freeform curve, right? So you can see here they have numbering, we have template. So I would draw on computer. They use plywood to mock up on site to check that it's feasible. Then only I issue all these drawings to the stone cutter where they laser cut out each of this, right? So this is like the process, and then you can see that the infill is just regular rectangular shape, and then the piece near the edge they have to trim. That's about it. Okay, so surrounding the all this area, then of course all the walls are also free form, and then this is how they were constructing the different lines of the wall. So you can see here on the right here, you see the last piece will be trimmed, but otherwise it's pretty straight, right? And this is how the stone is hung for the wall. So this is some of the, again, the construction details that we have to draw to make sure the water flows, to make sure. So in fact, this is a paddy field, it's grass, right? And then if you walk up, you will get to the pool level upstairs, right? So we have to detail, and this is kind of the finished product. And then there are other elements that's also, so everything is complex. Then this is the gate. The gate is to shield visual, is to give visual privacy, but then we want air to flow through. So this is the triangle, but the triangle is kind of like slanted, right, in on plan, and it's also made of all the same members of all the same sizes, very thin plates. So on the left is the model that I made, and then on the right is the actual gate itself. Okay. So we use more modeling a lot. So sometimes I build, and sometimes my colleague. So this is my colleague, building all this very intricate. This is a staircase. by hand, right? And then on the left is we are simulating this other carpentry, the bed head. So even that is made of triangles. And then we also use model because the drawings not enough. So in addition to drawings, we have models and we have 3D models. So and mock up to see the lighting effect. This is for the carpenter. So eventually, carpenter also did a 1:1 mock up in the factory, but I can't show those photos. So yeah, so that's about it. So um this is how the house was built, and we built along models in the office. This is the office. And then because what did I say? Yeah, in the office there's a lot of mobile. The furniture in the office all mobile, and it can change. This is coming from my initial interest of all the nomadic structure, right? That you can just pack and go. So I do a lot of this kind of mobile furniture design for some of the other projects, but they don't quite fall into all this category. But it's kind of like the initial interpretation of what nomadic structures are. Okay, okay, that's about it.
Okay. Thank you so much for your talk. So I think does anyone have any questions? Okay, maybe I can start with just general questions that I have. I don't have any background in architecture, so I'll just like ask based on what I've seen in today's presentation and talk, which was very interesting to me. I think there's like a move or like generally towards like regenerating like abstract forms in architecture.